Welcome to the presentation on while loops. Let's do something over and over. There's going to be times within the programs that you write where you want to give the user the ability to restart the program or to do an activity within your program over again or repeatedly. For example, if you developed a video game and at the end of the game you want to give the user the ability to start the game again or to end the game. If we want to play the game again, then a loop is well suited for that so that they could say yes, they want to play again, and it goes to the top of your program and starts the game again. The while loop executes a statement over and over as long as the Boolean expression is true. The expression is evaluated first, so the statement might not be executed at all. For example, if we ask the user, do you even want to play the game? They may say no. In fact, then the loop would not execute and the game would terminate. The expression is evaluated again after each execution of the statement until the expression becomes false. The while statement has the following syntax. While is a reserved word. The condition is evaluated and it's going to be a Boolean expression. So if the condition is true, the statement is executed. Then the condition is evaluated again. The statement is executed repeatedly until the condition becomes false. Let's take a look at the logic of a while loop. So we have our condition to be evaluated. Again, remember this is going to be a Boolean expression that's going to evaluate to true or false. So we evaluate the condition. If the condition is true, then we're going to act on the statement and evaluate our condition again. If we evaluate the condition and it's false, we skip the statement and we continue on with the rest of our program. The while statement. If the condition of a while statement is false initially, so that means before you even go into the loop, we evaluate the condition and it's false, then the statement's never going to be executed. It simply will be skipped. So therefore, the body of a while loop will be executed 0 or more times. And a sentinel value indicates the end of the input. We want to make sure we're telling the user what the sentinel value is. A lot of times it might be -1 or an end for no, but definitely want to indicate that in the printout so that they know how to terminate the loop. A loop is used to validate the input, making the program more robust. Let's take a look at some examples. This first program is Counter. The Counter program shown here simply prints the values from 1 to 5. Each turn through the loop prints one value, then increases the counter by 1. A constant called limit holds the maximum value that count is allowed to reach. The condition of the while loop means that the loop will keep going as long as count is less than or equal to limit. Once count reaches the limit, the condition is false and the loop quits. Please pause the video if you need additional time to study the code. Let's look at another example. This is the average program. The average program shown here reads integer values from the user, adds them up, and computes their average. We don't know how many values the user may enter, so we need to have a way to show that the user is done. In this program, we put 0 to be the sentinel value, which is a value that shows the end of the input, the way a sentinel stands guard at the gate of a port or the perimeter of an army's camp. The while loop continues to process input values until the user enters the 0. A sentinel value must always be outside the normal range of the values entered. In this program, a value called sum is used to keep a running sum, which means it is the total of the values entered so far. The variable sum starts at 0, and each value read is added to and stored back into sum. We also have to count the number of values that are entered, so that after the loop finishes, we can divide by the right number to get the average. Note that the sentinel value is not counted. Please pause the video if you need additional time to study the code. Here's a third example. This is the win percentage program. The win percentage program computes the winning percentage of a sports team based on the number of games won. We will use a while loop in this program to validate the input, meaning we guarantee that the user enters a value that we consider to be valid. The while loop keeps executing repeatedly, asking the user for a valid input. until the entered number is indeed valid. Validating input data, avoiding errors such as dividing by zero, and performing other actions that guarantee proper processing are important design steps. We generally want our programs to be robust, which means that they handle the errors, even user errors, well. Because when users make errors, they blame the program, even when it's their own fault for making the error. So we want to kind of think about what are the incorrect things the user is going to do and try to put in safeguards for that. Please pause the video if you need additional time to study the loop code. Infinite loops. The body of a while loop must eventually make the condition false. If not, it is an infinite loop, which will execute until the user interrupts the program. This is a common logical error, especially for beginning programmers. You should always double check to ensure that your loops will terminate normally. Let's take a look at the Forever program. The programmer must make sure that the condition of a loop will eventually become false. If it doesn't, the loop is going to keep going forever, or at least until the program is interrupted or the user's computer runs out of RAM. The infinite loop, like the ones shown here again, is a common mistake. Can you spot the error in the code? Pause the video if you need a moment to study the code. When we look at the while condition, you're going to see it's count less than or equal to 25. But within the statement of the while loop, you're going to see that we are decrementing count. So count, which initially started at 1, is going to go to 0, -1, -2, -3. So the condition is never going to be true. We're never going to get higher than 25. So therefore, we've created an infinite loop. Nested loops. Similar to nested if statements, loops can be nested as well. That is, the body of a loop can contain another loop. Each time through the outer loop, the inner loop goes through its full set of iterations. Here's an example of the Paladone program. The code here contains two loops, one inside the other, nested loops. The outer loop controls how many strings are tested, and the inner loop scans through each string character by character until it determines whether the string is a palindrome. Please pause the video if you need additional time to study the code. Iterators. An iterator is an object that has methods that allow you to process a collection of items one at a time. The hasNext method and the next method are used to loop through the collection. Let's take a look at the code. So here we've got while myCollection.hasNext. So what's going to happen here is we have this myCollections object that has multiple items contained inside. So the hasNext method has to look to see if there are any more objects that are coming. As long as there's more objects to evaluate, then we can go ahead and we can print the next item, which is what the next method does. If the hasNext method looks ahead in my collection and sees that there's not another item, then that condition becomes false, and then we don't print anything on the hasNext, or I'm sorry, on the next, because there is nothing coming. Several classes in the Java class library define iterator objects, including scanner. And we'll talk about iterator objects a little bit later when we get to arrays. So let's practice. So here we have a while loop, and we've initialized the variable j to 1, and so our condition is while j is less than 8, we're going to increment j, and then we're going to print j. So let's trace through this loop together. I have my loop here on the screen. Looking at this loop, what are some of the things that are going to change as we go through the loop, or things that you have to keep track of? We're going to draw a T-chart. This is called tracing, and I can tell because I'm going to increment j, I need to keep track of my j value, and within the body of my loop, my statement has a print. So we're going to be printing j, so I'm going to need to keep track of my print. And notice it's a print, not a print line. So that means it's going to go horizontal. So I've initialized j to 1, so I'm going to put a 1 underneath my j. I'm going to come into my condition, j less than 8. Well, 1 is less than 8. That's true. So I'm going to increment j. j becomes 2. And then I'm going to print j. So I'm going to print 2. I'm going to come up. I'm going to test my condition again. Is j less than 8? Well, j is 2, and 2 is less than 8, so that is true. So I'm going to increment j by 1, and I'm going to print j, and j is 3. I'm going to come up to my condition. Is 3 less than 8? That is true, so I'm going to increment j by 1. J becomes 4. I'm going to print j. I'm going to test my condition. Is 4 less than 8? Well, that's true, so I'm going to increment j, and then I'm going to print j. I'm going to come up and test my condition. Is 5 less than 8? Well, that's true, so I'm going to increment j to 6, and I'm going to print j. I'm going to test my condition. Is j less than 8? Well, j is 6, and 6 is indeed less than 8, so I'm going to increment j to 7, and I'm going to print j. I'm going to come up and I'm going to test my condition. Is j less than 8? Well, yes, it is, because 7 is less than 8, so I'm going to increment 8, and I'm going to print 8. I'm going to test my condition. Is 8 less than 8? Well, now I just got false because 8 is not less than 8, and I've terminated my loop. So my answer in this particular case is 2, 3, 4, 5, 6, 7, and 8. So if you tried to do this in your head, a common mistake of people doing this in their head is that they tend to be off by 1. So if you did it in your head, you might have thought the answer was 2, 3, 4, 5, 6, 7. Because as soon as you saw that j became 8, you thought you were done. So tracing is a really good strategy, and I encourage you to get out paper and trace all of your loops. And even on the AP test, this can save you a lot of time. You're thinking, well, Ms. Rush, tracing takes quite a bit of time. That is true. But on the AP test, when you're going back and you're checking your answers, you've already traced it, so you have to just go back through your trace. Thank you for watching, and let me know if you have any questions.